Great. So now welcome back to grade 7 math again. We are now on chapter 5.4 and we are on 5.4b because we're continuing on trapezoids. There are two special types of trapezoids that we can look at, and the first one is one that has a right angle already in it, which means that it defines the height. This is called a right trapezoid because one of the side lengths is already giving you the height of the trapezoid, so you don't need to find the height because it's given to you in one of the sides. Another special type of trapezoid is one where the two side lengths are exactly the same length. In the right trapezoid, they are not. If they were, it would be a rectangle. And in this case, we have two identical sides, but it's not 90 degrees, and we call this an isosceles trapezoid, just like an isosceles triangle with his head chopped off. So that's really the same thing. Now, so those are two special types of trapezoids. Now, working backwards, let's say we have this problem that we have a trapezoid that has an area of 24 centimeters squared. The parallel sides have lengths of 10 centimeters and 2 centimeters. What is the height of this trapezoid? Well, let's just draw it on the side, just so that we have an understanding of what it looks like. We can assume it's a regular trapezoid or an isosceles trapezoid because actually it doesn't really matter, because a right trapezoid, isosceles trapezoid, or even a scalene trapezoid with different side lengths would all have the same area. What would be the difference would be its perimeter, and we would have to know the side lengths that are not parallel in order to find the perimeter. But in case of the area, and you could try this out with a few trapezoids, you'll still get the same area even if the side lengths are moved. The big base and small base are moved in different ways, as long as the lengths stay the same. So the parallel sides have lengths of 10 centimeters, so that's the big base. Small base is 2 centimeters. We don't know the height. That's what we don't know, but we do know its area is 24 centimeters squared. So let's just write this on the side. We know that 24 centimeters squared is the area. Big base is 10 centimeters. Small base is 2 centimeters. And we don't know the height. I could also make it into a list and put area of the trapezoid is 24 centimeters squared. Big base is 10 centimeters, small base is 2 centimeters, and height, we don't know. Whichever way is easiest for you to organize the information, use that. So as soon as you have all the information, then I can calculate and use the formula. So let's just rewrite the formula. If you want to pause the video and try to remember it without looking up at the rest of the sheet, remember that the area of a trapezoid is, first of all, we need to double the whole trapezoid and make it a parallelogram. That means we need to add the two different types of bases, big base plus small base, and then I multiply by the height to give the full big parallelogram, and then I'm going to cut that in half to find one half of it, or find one trapezoid from that big parallelogram. So big base plus small base times height, and then all divided by 2. And big base plus small base has to be done first, because according to orders of operations, we can't multiply by the height first. We have to find the two bases together first. So the area of a trapezoid, on my calculator, I will type in 10 centimeters plus 2 centimeters times the height we don't know, then divide by 2. Well, the area of the trapezoid, we were told, is 24 centimeters squared. And the big base is 10 plus 2, which is 12 centimeters. Now, let's think of this again. We have a trapezoid, which has a total big base of 12 centimeters. But what I really need this for is for this to be a parallelogram. So I need to then multiply my area by 2 to make it a full parallelogram again. So now this divide by 2 is going to go to the other side, because now we're going to multiply it by 2. So 24 centimeters squared times 2 makes this now a parallelogram, which means the total big base, 12 centimeters, times its height. So now my big parallelogram is 24 centimeters squared times 2 is 48 centimeters squared, is now my big base, or my giant base. We'll call it the giant base. Giant base times height. So 12 centimeters times height. And now to undo that one, I'll bring this over again, and now I'll divide because that's the opposite of multiplication, because I need to undo this problem. So I have my 48 centimeters squared. This was a multiplication. When I want to undo it, it becomes a division, and I'm left with my height. So 48 divided by 12 is 4. Centimeters squared divided by centimeters, I'm working backwards, gives me a centimeter again, and that's my height. If I wanted to check my work, then I could go back to the beginning and plug in my answers. Is the area of a trapezoid 10 centimeters plus 2 centimeters times 4 divided by 2? I'm removing the units because I'm just checking to see if the numbers are right. So then using this, area is equal to 12 times 4 divided by 2. Area is equal to 48 divided by 2. Area is equal to 24. Does that match my original area? And yes, it does. Because I can check, I see that this was the answer. That means my height is also correct at 4 centimeters. So now that we've solved this problem, it's a little tricky working backwards because you have to make a trapezoid into that big parallelogram and then work backwards from there. So hopefully you understood this lesson, and we'll do some practice questions in class.